Hello, welcome to Telcoma Global. So today in this class we are going to discuss about a new course series that is about LT call flow with Wireshark. So here in this course we will discuss about the various LT call flow by analyzing the trace files in Wireshark software. So here in this our first chapter is about eNodeB setup call flow. So before starting with the eNodeB setup call flow, let's discuss about the Wireshark. What is a Wireshark? So here this is a Wireshark launch window, and Wireshark is a network packet analyzer tool which is available for free, and it is as it is a open source software. So here it is one of the best packet analyzer available, and it is used by network administrator to troubleshoot the network problem, and it is used by the security engineers to examine the security problems, or by a quality engineers or by the developers, and it is also used by some people to learn the network protocols. So here in this software we can do the live capturing or import the file of packets, or we can also export the capture packets. So here for doing the live capturing we can select any media from here. Like here I am connected to the Wi-Fi network, so I can capture the Wi-Fi network Wi-Fi packets from here. So I will select the Wi-Fi media from here, and it will start capturing the packets that are ongoing in the Wi-Fi network. Whereas in this we can also import files of packets from many other capture program. Like we have pre-recorded some trace files and we want to open it. For that you can select this open, and you can also select the files from here. And here we can also export the capture packets file to the many format. So here you can also capture by using the filter. Like if you want to filter only TCP packets in the network, so you can write here TCP and it will only capture the TCP packet in the network. Whereas if you want to filter out the HTTP packets, it can also capture only the HTTP packet if you write here the HTTP. So it will filter out the HTTP packets from the whole network packets. So here before starting with this eNodeB setup call flow, let's discuss about the call flow first. So here let's start with the our course, that is LT call flow with Wireshark. So here in this our first chapter is about eNodeB setup call flow. So here we know that in wireless network the LT call flow passes through many steps through its during its end-to-end signaling, and here it traveled from user equipment to the evolved node B, then to the mobility management entity, that is MME, then to the HSS, that is home subscriber server, then it goes to the serving gateway SGW, and then it will go to the PDN gateway, that is the PGW. So here in this way the call flow will take over. It will start from the UE and it is goes to the serving gateway and then to the PDN gateway. So this is about, so let's discuss about how the call will initiate, how the signaling will initiate in the network. So it will start with the eNodeB setup. So here this is the architecture of the 4G LTE network. So here you can see that the U is connected to the eNodeB using this UU interface, and after that the eNodeB is connected to the MME by using S1 MME interface, and it is directly connected to the serving gateway with the interface, that is S1U interface. So here after that the MME is further connected to the serving gateway by using S11 interface, and it is connected to the HSS, that is containing the permanent address of a user. So here it is connected through a S6A interface, whereas the serving gateway and PDN gateways are connected by using the S5 and S8 interface, and the PDN gateway is further connected to the IP network through SGI interface, and it is connected to the PCRF through the GX. So here the MME is the mobility management entity, and HSS is a home subscriber server, and PCRF here is the policy and charging rule functions. So here this is the 4G LTE network, and here in this network the eNodeBs are also connected with each other using the X2 interface. So this is a complete 4G architecture, and here we have to learn about these interfaces because the call flows is all about these interfaces, and we will learn about this in upcoming lectures. So here, before starting with the call flow, let's discuss about the functions of eNodeB and MME. So here the eNodeB, it supports the LTE interface, and here the function for radio resource management, radio bearer control, radio admission control, and the connections. And here it provides the mobility control, dynamic allocation of resource to UE in both uplink and downlink. And here it provides the selection of an MME at a UE attachment, and it provides the routing of user plane data towards serving gateway. It provides the scheduling and transmission of paging message and broadcast information, and very important, it provides the measurement reporting configuration for mobility and scheduling. So these are the function of eNodeB. Next we are going to discuss about the MME function. So here the MME manages mobility, UE identities, and the security parameters. So here it provides non-SS stratum, signalings, and security. Here it provides the idle mode UE reachability, tracking area list management, PDN gateway and serving gateway selection, and MME selection for handover with MME changes. So here it also provides roaming, authentication, and bearer management function. So these are the function of eNodeB and the MME. So let's start discussing about the call flow. So here this is the eNodeB setup call flow, and here all the signaling will take place in between the eNodeB and MME. So here in this call flow I have taken the two UEs or the two mobiles and then eNodeB and MME. So here in this call flow begins with S1 setup. So here this is the S1 AP S1 setup request. So this was the message that is sent by the eNodeB to the MME, that is eNodeB initiate an S1 connection with the MME. So here it shares this global eNodeB identifier, the PLMN ID, mobile country code, mobile network code, eNodeB IDs, and it also shares the tracking area codes and list of PLMN data that are being broadcast from this eNodeB. So this is the information that is shared by the eNodeB to the particular MME in which it is present. After that, to the response of this request, the MME will send the message that is S1 AP S1 setup response. Here the MME accepts the S1 connection. So here in this particular message, the MME will provide the list of served GUMMEI, that is the globally unique MME identifier. Then it shares the LTE pool information, PLMN, MME group identifiers, and the MME codes. So this is the information that is provided by the MME to the eNodeB for the S1 setup. So here in this, the eNodeB requests the MME for the information, and MME provides the information with the response message. So in this way they provide they make the S1 setup connection in between eNodeB and MME. After this, the system will start sending the S1B and MIB messages, that are system information block and master information block information with UE. So if this is sent because eNodeB want to send the broadcast information to all the UE that are present in that area, in that tracking area, so that they remain synchronization to the network. So here, like here UE1 wants to initiate the call, or he wants to make the call. So to make the call, it will send the message that is RRC connection request. So here it will send the RRC connection request, and to respond to that, the eNodeB will provide the resources to initiate the call or to transfer the data with the message RRC connection setup. So in this way, this eNodeB setup call flow will work. So let's discuss about the trace files. So here I am opening the pre-recorded file of the eNodeB setup. So here you can see that I am opening from here, that is eNodeB setup.pcap. So pcap is the format of the Wireshark files. So as I click here, it will start open. sorry. So here this is the main window of the Wireshark. So here in this main window, this one is the menu bar, that is we can select from here like file, edit, view, go, capture, that you want to capture the package, or you want to analyze the package statistic, you want to make the input output graphs, or you want to know the endpoints, packet length, etc. And in telephony you can select these protocols and you can capture the packets according to these protocols. And this is for the wireless network. These are the tools of the Wireshark, and this is for the help. And then this menu, after that the menu next, this one is the file name, and after that this menu is about the this menu is known as the main toolbar. So here in main toolbar you can see that this is for starting capturing packet. If you want to start capturing the packet, you can select it. This is one for to stopping the capture. This one is for the restarting the current capture, and this one is for the setting. If you will click it, you can select from here any of the media and you can start capturing the file. After that, this one is for opening a previous file, and this one is for saving it, and this one is for closing it, and this one is for reloading the file. And these are the other toolbars that are used to like this one is for doing the down to selecting the packets, and this one is for up, this one is for searching the particular packet as well. So this after that this toolbar is known as filter toolbar, and here you can write any of the protocol that you want to capture, and that protocol will capture here in this particular trace file. After that, this window is known as the packet list pane. The number of packets that are captured are displayed here, and here it will provide the number series, then the timing of the packet when they are captured, then the source file, then destination, and then the protocol on which we have captured this packet, and then the length of the packet and its information. And this window pane is known as the packet detail pane. Here you can get the detail of the particular packet. If you select this packet, it will provide the detail of that particular packet. And this one is the packet byte pane. If you select this 10 number packet, it will provide the bytes that are transferred over here in this packet. So these are encrypted one, you can't read it. And after that, this last one is the status bar. Here you can select these, like here if you select this, it will open this window, that is Wireshark expert information, and in here it is also providing the name of the file. Here it is showing that here we have captured total number of 16 packet, and it is displaying 16 packet in total. It means no packet is lost here in this Wireshark trace file. And here from profile you can select any of the profile, like if you will select Bluetooth, the window pane will change, and if you will select the classic, then again it will change. So from here you can select any of this profile. So let's discuss about these packet, our call flow about the eNodeB. So here you can see that our first packet is about, that is sent by the source to the destination, that is S1AP S1 setup request. So here eNodeB sends the message to the MME for the S1 setup request. So it means this is the IP address of the eNodeB, and this one is the IP address of the MME that is receiving it, and to response to that it is sending the message, that is S1 setup response. So here you can see that the MME is sending, as MME is now source, it is sending the message to the eNodeB. Similarly, the many other eNodeBs that are present in that particular MME tracking area, they are requesting for the S1 setup to the MME. This MME, you can see that the MME IP address will remain same throughout this conversation. So it means there is one MME and multiple eNodeBs are sending the message for the S1 setup connection. So here if you will select, like here I am selecting this S1 setup response, here you can see that in this packet detail pane, the frame 6, it is showing that this is a frame 6 and it contains 102 byte on the wire, and we are captured 102 byte totaled on over the wire. So here we have captured these over the Ethernet wire, and you can see that it is showing a detailed information like the arrival time of this information, the frame number, frame length, capture length, etc. And here And then it provide that it is captured over the Ethernet cable, and the source name is this, and its MAC address is this, and destination name is this, and the MAC address of the destination is this. So this is providing the MAC address information. After that, it is providing the IP address information. So this is IPv4 address, and source address is this, destination address is this, and similarly you can see that it is showing the detailed information about this IPv4 protocol. Like protocol that we are capturing is about HTTP, and header checksum is this, the source, the destination IP address, and so on. So next it is showing the protocol, on which protocol we are capturing this file. So this is stream control transmission protocol, and the source port is this, and the destination port is this. After that, it is showing S1 application protocol, the name of our protocol, and it is showing this is the successful outcome, as it is providing the successful response to the S1 setup request. Similarly, if you will select this S1 setup request, it will show that this is the initiating message that want to make the connection. So here, as you will select this, here you can see that in packet byte main, it will select the particular bytes that are representing this information. So this is about how the eNodeB setup call flow will work. Here it will work like by making the S1 connection by sending S1 setup request and S1 setup response. So after that, when it will make the S1 connection, the network will start sending the S1B and MIB information, and after that it will start, if UE wants to initiate the call, it will request for the RRC connection further on. So this is all about the eNodeB setup call flow. Thank you.